Well, we have a question which is set out here. It says ABCD is a quadrilateral, has four sides. It's not drawn in. Only the coordinates are A is -3, 1, B is 5, -1, C is 3, -4, and D is -5, -2. All right, I've roughly sketched an XY axis. I haven't put X and Y on here, which I should have. And I haven't drawn the lines, but part A, find the gradient of AB. So we want the gradient from A to B. So let's see if we can do that. Can I get extended space here? Oh, looks like I can. All right. So the gradient, let's work in black. I will put the rule is gradient M y2 minus y1, x2 minus x1. So I'll call this point 1, and I'll call this point 2. So that's x1, y1, and that's x2, y2. So substituting in, I could have done y of b minus y of a if you like, that's fine. Y2 is the second y value, which is -1. Minus, and y1 is over in point A. The x value of point B is 5, and the x value of point A is -3. So we get -2 over 5 minus negatives plus 5 plus 2 is 8. So we get -1/4 if we simplify that. All right, part B, the gradient M of BC. I'll just put, I'm going to use the same rule every time so we don't get confused. This time my y2 is point C and my x1, y1 is point B. So y2, so that's the -4 minus y1 is -1, and the x2 is 3, and the x1 is 5. -4 plus 1 is -3. Over -2. So it's 1.5, or 3 over 2. Got a gradient of 1.5. That makes sense. So if you look at the gradient from C to B, it goes up 1.5. Across 1, it goes up 3 across 1. So that's a gradient of 1.5. All right, part C, the gradient of AD. So this is the gradient of AB. That's the gradient of BC. Now we want the gradient of AD. So that will be y2 minus y1. I'm just going to stick with the same gradient rule. Second point is D. First point is A. So y of D and y of A. The x of D and the x of A. -3 over -4. Did I make a mistake? -2. No. I'm doing AD, right? So -5. I did make a mistake. It's here, you probably spotted it. y2 is -2, y1 is 1, x of D is -5 minus x of A is -3. All right, so well done if you spotted that and were calling out and I just wasn't listening. Sorry about that. All right, but well done for spotting it. -5 minus -3. x of a. Yeah, that's working. Let's make it not so thick. Okay, so -3. So -5 plus 3 is -2. That becomes positive 1.5. Good. And finally, I think I can fix this. Yep. D, not so wide. The gradient of DC. y2 minus y1, x2 minus x1. So the second point now is C. So y of C is -4. And the first point is D. Y of D is -2. X of C is 3. X of D is -5. Okay, let's get this right. -4 plus 2 is -2. And 3 plus 5 is 8. You get -1/4. And so, is this a parallelogram? Well, DC is opposite AB, and the gradient of AB is -1/4. The gradient of DC is -1/4. So DC and AB are opposite sides, both gradient -1/4. CB and AD. CB and AD are opposite sides, and both gradient equals CB. Let's make this green. CB, AD, both at gradient 1.5. So the answer is therefore yes. ABCD is a parallelogram. Make sure you explain and show your setting out. There's no perpendicular sides here. Remember, to prove perpendicular sides, the gradient of AB multiplied by the gradient of, say, AD, if the gradient of AB times the gradient of AD, if that equals -1, then they are perpendicular. Yeah. So you simply multiply the gradients together to get -1. Here, AB is -1/4, and AD is 3/2, or 1.5. I'll just leave it as 3/2. And you do get a negative, but you get -3/8, therefore not perpendicular. All right. If that was -1, we'd say yes, they're perpendicular, but not. They're not. It's not a right angle in that position. But yes, they're parallel. So I'm going to put a single arrow on those, a double arrow on those, just to wrap it up, because yes, they're the same gradients and it's a parallelogram. Cheers.